beautiful reflections through water in this room, I would have used that to put my slide, but maybe not for another reason. What you see here, the title of the talk is Reflected in Water, because so much, in my view, is reflected in water. And what I will try to entertain you with is the reflections on development, on resilience, and on inequalities, which is something I care very much for, in fact. And what you see here reflected in the waters of my hometown, Venice, which is a good omen, a good example, in fact, of how should we stand the fragility of a city with what is expecting us. It's still quite important, actually. So what I want to be, I have different, I have mixed feelings on how technical the talk should be. I will keep it to a relatively low level. I'd be delighted if you have any interaction, any possible interaction on technicalities that you have in the place. But my essentially, in a nutshell, my assumptions is that the climate is changing rapidly, very rapidly, in fact, and so should we. That's the main thing, of which I'll have a few reflections to share with you. And in particular, what and how could be the engine of change? In fact, facing the invisible structures, that is the consolidated, the privileges acquired in time, the uses and the things, the collective feelings and the political organizations, the structures, etc., that make it so difficult, in fact. Not perhaps in Sweden, and yet we'll be getting back to the Sweden condition fairly soon. So my thesis is that the key issue towards a fair water governance, in fact, pertains to the global north and the global south equally, and they demand urgent reflections, in fact, about the relationship between a number of issues which I'll be covering in this talk. And I begin with a picture I took on the banks of a Magna river, the mighty Magna, one of the tributaries of to the gigantic Ganges-Brahmaputra deltaic system in Bangladesh, in fact, next to Dhaka, next to a place called, believe it or not, Matlab, Bangladesh, which is an interesting place for a number of reasons. And what the young boy was telling me is that the sacred waters couldn't be able to bring any harm, in fact. And what made this particularly interesting is the fact that this happened like a couple of hundred meters downstream, and downstream means a lot if you remember that the role of advection and the role of hydrodynamic dispersion, in fact, to the largest hospital in the world dedicated to diarrheal diseases. It's and what happens is that at that time I had just visited it, and what was remarkable, it had something like 70 cases diagnosed, probably properly diagnosed cases of cholera in the place, which cholera is what water and health is something which you'll be finding across this talk a fair amount of times, so what I'll be doing for a long while. And why this is significant, because even answering such a simple question, but will the guy catch cholera, is in fact impossible to answer for a number of reasons. Hydrodynamic reasons, for the fact that if you, and there are great experts here in dispersion, you know that predicting point-wise concentration in space and time gives you almost zero probability of hitting it. And in a context in which you don't know what's the boundary condition, you know how the containers of the sewage system of a hospital will bring in, not to mention the fact that you wouldn't be able to know the survival, in fact, of a Vibrio cholera, that is the pathogen, in a water environment of this time. But what is significant is that you catch cholera if you ingest enough pathogens, in fact, and depending on the size of a person, how healthy he is, etc., you catch it or not. But the fact that we cannot even answer such a simple question, will the guy catch cholera, yes or no, it's a permanent liability on our ability to put a price tag of ecosystem services, in this case, clean water, clean drinking water. And that's it's an important part of a discussion, that the weakness of our predictions and how we can overcome that, and why perhaps, probably, exactly the idea that in certain cases reflected in water, we can put a price tag on ecosystem services. In fact, it's a very important part of this reflection. And the first thing I want, of course, just to support the first assumption that we have, I'll be showing you something which I do not want you to retain, but the general trend. This is a fairly famous collection of graphs by Stefan and others, and published in the Anthropocene reviews, and it shows social and economic indicators. In the next slide, you're going to see the biogeochemical measures that have a peculiar feature. I don't want you to just get involved with the units of measure or with any particular the timetables that were there, but essentially it's something which we had measurements, and those measurements are something which essentially we started measuring at the beginning of the 18th century. Uppsala, of course, is a great addition, but also Padua, my alma mater, in fact, the first chair of hydraulics ever, and the time series of a daily precipitation in Galileo's observatory, in fact, has been taken daily since 1710. And so more or less regularly we have measured, in this case, what we're seeing here, population, the gross domestic product. We have foreign investment, that means also land grabbing, on which we could have like a separate lecture about how market behaves in the absence of public control. Population, primary energy use, water use, and large dams or paper production, transportation, telecommunication, you have a lot of them. What I would like you to retain is the fact that essentially nothing changed from the beginning of the 18th century to the 50s of the last century, to 1950s. And a quiet Holocene in which nothing was happening, essentially, followed by what is now popularly called the hockey stick diagram cycle. That is something in which at the more or less synchronously, and this is not something cherry-picked by the authors, because it happens to a gigantic number of indicators, but it's like some sort of reaching the tipping point in which everything simultaneously in completely different fields, I'm talking about social and economic indicators, in fact, they will jump up without boundaries. The hockey stick diagram, and the Swedes are sensitive, of course, to the hockey issue. And I return on a few sports things. And this happens also to indicators of biological turbation, all of them, etc. I'm talking about, of course, in the reduction to one factor, obviously, this is a consequence of one single thing. If you reduce it to one, it is the increase of the temperature of the atmosphere, of course, and that Clausius gets very heavily into the picture, of course, not Linnaeus, but Clausius. Of course, the Clausius Clapeyron, for every degree more of temperature of the atmosphere, that atmosphere holds from 6 to 8%, depending on the conditions, etc., of water vapor into that. This is water. And that is due essentially to the effect of, as everybody knows, of greenhouse gases. And here you have the concentration of carbon dioxide, which was measured fairly well since, early on. And the idea of measuring is rooted in this very place, of course, because Clausius was central about it. It's called Clapeyron, because Clapeyron had the idea, but the formalization was given by Clausius, in fact. Now, nitrous oxide, methane, which is 20 times more effective greenhouse gas, but you get the stratospheric ozone, which is in fact one of the only places in which we did have you remember the origins of the Anthropocene. You remember Crutzen and Molina, in fact, and the fact that much better than I do, etc. But it's the only place in which we just somewhat leveled what was happening because we ozone hole. But if you go at surface temperature, measures of acidification of the ocean, or whatever measure of the exploitation of the environment, up to the loss of tropical forests, domesticated land, whatever you have, all of them have the same feeling. This is telling you a coherent story. And it starts in the 50s of the last century, in fact. And if you want, this is not, in that case, it was done partly by measuring, and until you said, now we have like a huge number of tools, and or inverting the arrow of time in models of climate. So essentially, you can go back until the noise clouds the signal. But these are measures, in fact, in Greenland, as you see from the Grace FO observatory. In fact, what you have is that this is not things. This is measured. It's in gigatons of loss of ice. In fact, registered in the last 20 years. It doesn't take a genius to see if the thing is accelerating. But the message is climate is changing rapidly, like it never happened in the history of the planet, because of course we had periods in which, and again, this is not my field, but I take it from the literature, in which the change, like 1 to 4 degrees or whatever happened in 1 million years, not in 100 years. So the rapidity is that the message I want you to keep. And to explain what rapidity means about getting back, like when Marco Polo was lecturing Kublai Khan, he was saying, why didn't you mention Venice? Because he was talking about cities he visited. And Marco Polo said, whenever I speak about other cities, I speak about Venice, which is my hometown. So I hope you don't mind. And this is Palazzo Cavalli Franchetti, but something tricky in here. The picture is capsized, is upside down. It was taken during the lockdown. And this is a great example, I think, that shows that that in this case, so it was the Grand Canal was so still because of a lockdown imposed because of the pandemic. And our generation, we thought that war, famine, and pandemics would be spared of us. None of them is spared of us, including famine, because when Putin blocked the Ukrainian cargo, in fact, the MENA countries suffered because they didn't have any grain. But what is remarkable about this is that pandemics have always been in the place. In fact, it's always been. In the 17th century, 1660, it was the last bout of a Black Plague, in fact, that killed half of the population of Europe, in fact. But then to become a pandemic took something like 100 years, 40 to 100 years, depending on the places, and to do extermination that he carried out. It took only one flight from Wuhan to Toronto to make it pandemic in 2022. So the message is the rapidity is what is new and what has never been not only seen by Homo sapiens, whose duration on this planet has been so limited, but in the history, in fact, or history, the meta-history, as if you want. And then, so what are the issues that we need to discuss? First of all, I got an introduction about consequences of these. And being a hydrologist, we're talking about floods, we're talking about droughts, and we're talking about the fair distribution of water, all of them linked completely together. And what you're seeing here, in fact, is what happened in 2022 in Pakistan. You had the monsoon completely altered, and for months you had these kind of behaviors. This is also interesting because it happened in Italy on May 13, 2023, which is remarkable for another reason. It's a flood. Floods are floods are floods. And it always happened. And I return on that. But what happened is that there are two signs that are very significant on which I shall return. First, the fact that this happened like a week after the end of a deadly drought that hit very seriously the northern Italy. I'll be showing you a defect of precipitation later on. The second thing is the effect of the Anthropocene, because when the breach happened, the river abandoned completely the thing. You see that not a drop of water remains in the water course that was designed by man, meaning that the Anthropocene pitches in fairly importantly. Not only that, there's something which has a technicality on which I share it, which is a very alive, in fact, issue of modern contemporary hydrologic research, because the same thing happened, not again, but is when you have an event of that kind, you typically do something in which you foresee that the return period, which is the inverse of a probability of exceedance of an event that generates the disaster, occurs in the order of 200 years. It happened the following year, 2 years in a row. So you doubt there's something wrong in there. There's something really wrong. And on this, I want to return. And this is what I wanted to entertain you on. And it's called that, actually, I had notes which I forgot, but I don't mind. I'll get back to that in case. So what happens is that the punchline is a nice one. It's called the future is not what it used to be, which is a statement which is funny and deep at the same time. It has wide attributions. One is a French philosopher, Paul Vidal. Another is a baseballer, Yogi Berra. In fact, you see, the future ain't what it used to be for different reasons. Because if you are a reader of Stephen Jay Gould, you know that you see reflected in the evolution of the statistic of the 0.4 batting average in baseball, you see the effect of biological evolution, which is a phenomenal piece of work. If you haven't read Full House, in fact, it's a marvel to have it. But what is interesting is that the thing that we are somewhat assuming in management of water effects that somewhat you draw from a distribution doesn't change in time. So essentially, you see that the envelope of variation of the events that you are designed to defend from, you assume that it's a given envelope, unchanging. Forget about that. Now, a famous article in which led by Chris Milley, in which Malin Falkenmark, whom I remember fondly, in fact, called Stationarity is Dead, with the water science. Where are we going with water science? The fact is that distributions are non-stationary. It is, you don't learn from the past. The future is not what it used to be in the sense that the probability distributions that allow you to calculate the probability of exceedance and thereby the security that you have and the design levels that you have are not drawn from the same distribution. And that's something quite important. There's a very alive field of statistical hydrology dedicated to metastatistics, that is, systems in which you do not assume stationarity of a distribution. Essentially, you treat parameters of distributions as random variables as well. And what you see is that when you start exercising that on with these metastatistics tools, etc., applied to the records that you have on measures that you have decently enough, you see that the change is majestic. So the effect of the rapidity of a change is quite remarkable. Oop. No, here it is. Nope. I see. This one is also, but it's also interesting because it's a painter, 1546 newspaper. Painting which you had in that, which you had in there. It's an interesting precursor of what we'll be discussing in a sense. Because you see the big picture is less interesting. The whole thing is that the saints Antonio and Crescenzio that are asking the Virgin Mary to forgiveness for the people that died in a flood that happened in that particular period. And what is interesting in the lower register, which you see enhanced in here, you see some of which are the ingredients of today's floods as well: muds, the color, the utensils that fly, the corpses of humans and animals, etc. There's something which gets a particular importance because in that case, what was obvious? There was the Anthropocene in action even in 1546, because the smelting industry, the nascent smelting industry and metallurgical, low technology metallurgic industry in that area to supply for the Feltre's next place next to Venice as well, generated a huge clearing of vegetation and huge training of rivers for that matter. So it was, in a sense, Jacopo Bassano, the author, was on a precursor, what you would call the modern feeling, the feeling that the entire construction of modern art, in fact, was something in which you would assume from then to minus infinity, there was a harmony between man and nature, which is far from happening, even at that time. And what is interesting, again, related to the particular punch of a time, you see, what you see in there is a simple Google map. Is an exercise I had, an undergraduate did it for me, actually. Just a Google map of the region, which you see the city of Venice and the mainland in there. And in there is an extraction which you get directly from those tools that these tools allow you to have. It is the built environment, it is infrastructure. And that's a reflection to how we treated our built environment, and how we expanded, in fact, the cemented part of a landscape, which has inferences on the flood, and then we shall see on the deep recharging, at least in undifferentiated aquifers in there. So it has plenty of water consequences. And why am I mentioning this? Because what you're seeing here is the first page of the Travel to Italy by Goethe, 1868 maybe. It was explicitly mentioning that the most beautiful road he's ever taken was taken that goes from Vicenza to Padua. Try to do it today to see how the Anthropocene behaved, and something which remains in the background or something we have to keep in mind. Again, we mentioned Clapeyron Clausius, and it's easy to realize that, in fact, the higher temperatures and the higher soil moisture content in the atmosphere generates stronger localized events. We complicate the scale issues because that they are bound to be disastrous for small and medium-sized catchments, catchments, or for the probability for larger and larger and larger catchment becomes less complicated. So the effect will be less prominent in there. But it's more complicated, but it can be done, in fact, to link the fact that bigger floods imply longer droughts and more pronounced droughts as well. And that's something which, one example again in that period, refers to the example of a river in Romagna failing that you see in here. Here is the meteorological, in fact, defect. That is, colors tending veering towards the red are the ones in which you are exceedance. I mean, less than the average is strongly red, and more than the average is the colors veering towards the blue. And what happens in the big drought that hit Europe, Central Europe, in fact, from the beginning of 2022 to April, more or less, of 2023, was being very serious in one place. But southern Italy, for instance, that now is lamenting significant thing, was much. In fact, they fared very well, in fact. And in reality, that also means that the erratic behavior, the consequences of the rapid climatic change on the distribution of water and snow, of rain, I mean, precipitation, that is, rain, very important for agriculture, snow, that the effect of gigantic in the distribution in space and time. And even to the point that there's something which here we discussed it quite a few times. So even in Sweden, you have a perception that this is something which not to us, non-nobis, not to us. It's something which you shouldn't care for it. Instead, you should, because those patterns are very erratic and they change very rapidly. In fact, not even in Sweden, you can assure that these kind of problems are set. In fact, if you take the driest place on Earth is a certain corner of the Sahel Desert, which I visited, in fact, in which you haven't got a drop of rain in 43 years. And if you just look from the observation from space, what you see there, you will see the trace of former ancient paleo rivers teeming with life at the time. No good fortune could last forever. And that's also relevant to the surrounding thing, or once will be hitting the main part of the thing, is that this is essentially the so-called cascade, the drought cascade. There are different types of droughts, all of them with different consequences. One is, of course, and what you see in there was the conceptual diagram by Chagnon, just 20 or 30 years old. And then what Darren Tekabi did relatively recently, that is something which can supply directly by measurements, direct measurements, not mathematical models, in systems in which you do have first the precipitation scarcity of or abundance, and you have runoff, that is the transformation to the storage and fluxes on the in water courses. Then you have stream flow later on, and then you have groundwater, the deep thing, which is very important, especially for domestic users. And that gets me to one of the first punches about inequalities, because it's still good for the global north to pontificate from a place in which you open the faucet, you get the water you need, the quality you need. Mind you that, and I'm talking about the figures I have very clear for my country, for Italy, is that the average consumption is of the order 260, 270 liters per day per person of the rotation. And we clearly we water the garden with potable water. We certainly don't use gray waters for, like, not even watering the thing, etc. It's just everything goes in there. And forgetting, and that's key for the debate we're going to have about adaptation or mitigation, is the fact that, mind you, that in the global south, the dotation, what a woman can carry on her head, going to filthy phreatic aquifers, like in this case, maybe walking miles to go back home, because that's typically in the labor distribution in sub-Saharan Africa. The role of providing the dotation of water for the household rests on the women and on the kids. And something which is important for that reason, because in reality, and that's, let's say, the hanging doubt that remains in there, the system top-down, that is mitigation. If I speak to my colleagues and friends meteorologists, distinguished meteorologists, in fact, no one believes that mitigation is the only way forward, it's the solution of a problem. I know, but do you think we might be able to tell 1 billion Indians to give up hard gain improvements in their lifestyles, like, for instance, using the air conditioner? Will you be able to tell the guys that are now deforesting where we don't want to say, no, no, you don't have to touch it, etc., when we destroyed our own resources and their own, maybe in more than one case? So the idea is that the kind of global, would you expect that a world in which America first is a world in which we'll be able to get the kind of global consensus that is necessary for the reduction of the emissions? We believe that in Europe in particular, in which we'll have to devote part of what we now dedicated to welfare to warfare in the future because of what happens in the America, will allow us to subsidize heavily the global South, because I don't believe we will be able to. So the only thing we have is the system bottom up, which is a system in which we have to adapt. So we have to say we are at the mercy of the change, and we have to find systems in which we have to preserve quantities, and we have to preserve qualities for the thing. That was a long introduction to tell you what I was trying to give you to get to the point. And this picture, I forgot lots of things that I wanted to tell you, and I don't know if I'd be able to catch them up later. But okay, one of the things that this picture gets us to sub-Saharan Africa, Burkina Faso, where I've been working. By the way, in my former lab, because I'm emeritus, I've been kicked out from all my labs actually. So we used to do mathematical modeling, theory, these experiments in the lab. I had a wet lab and much of field work, and there was what was particularly interesting to me. This happened in one of the 15,000 small dams that were constructed at the financing of the World Bank, and that gave up because it says the true cost of a high dam never shows up. So they decided to finance only small dams like this kind. 15,000 small dams of that have been built. And on this, I share return because it's a way in which the question we have is that will we be able to put a price tag, a proper price tag of ecosystem services? But it's something which we have there. It's something which I share return, and the true calculation of a value that you have in there. But the question is that well, I was supposed to do something completely different in here, but I will get him back to that. I tried to get some order depending on the slides, and I got carried away, as it happens to me quite a few times, I said. So the idea is to say, okay, so the point is that adaptation, but how? And for example, now we know that future large-scale water resources management plans make compelling arguments for including the reduction of the loss of biodiversity in the fluvial basin. In fact, we know the structure of river networks. In fact, as I'll be trying to show you in a cascade of results, in fact, is a template for propagation of deadly or debilitating disease. We can actually see the history of history in the water courses because population migrations, including the Neolithic transition, remember Cavalli Sforza and Amaran, in fact, is the Neolithic transition that shaped the composition of the human communities the way you see them today, are in fact affected by the structure of the river network. There's something written in there very much as well. And well, the idea I'm pushing forward with the examples which I try to make quantitative is that that we have learned to decode the water footprint, that is what is reflected in water properly, or how environmental factors have affected biological invasions, including the Neolithic transition I was saying, and whatever, and the biodiversity propagation, and the so-called river networks seen as ecological corridors, in fact, in their function, on which I'll be showing you a few technical results. But the idea is that social discounting applied to public policies that are concerned with the preservation and with the natural capital needs quantitative assessments. And the reason why we haven't been able to really put a price tag on ecosystem services in the past was that when you say that something is priceless, it means that it has no economic value whatsoever. And that's the inching towards that direction is precisely what we'll be doing. So the idea is that are we capable to provide sound economic arguments, in fact, for preventing development schemes in the light of, for instance, the propagation of disease that would include, because they never did it so in the past. And this kind of predictability is something on which we reflect a lot. And what you see in here, and I really hope there will be major recognition for Partha Dasgupta and Simon Levine on their take on the value of ecosystem services and values of the natural capital. The idea is that no economy can thrive forever, in fact, by mining the natural capital, by destroying ecosystems, by demolishing renewable and non-renewable resources, by damaging soils and the likes. And they only do it for a time, in fact. In reality, one of the reasons why, in fact, we have lost sight of a very important thing, etc., was largely based in the spin-offs of a theory of Kuznets, the economist that you see portrayed up there, but is somewhat simplifying. I can elaborate more if you are interested. It is the curse of the Kuznets curves. It's something which Kuznets was an expatriate of a Nazi Germany. He retired in Harvard. He got one of the first Nobel Prizes, in fact, for economics in there. And he came up with an analysis, an empirical analysis of a recovery of the societies after the Second World War. And what he came up with, I'm simplifying somewhat, I'm not doing perfect justice to Kuznets, but certainly to certain of his eponymous translators, or the translators of translators. But what happens is that the general feeling that allowed development economics to prevail at least until, say, the beginning of the century, in fact, was something which essentially a measure of inequalities plotted against income per capita, that put GDP of any indicator of wealth, and that's the thesis, does not give you the perception of the true poverty or richness of nations, to dub Landes rather than Adam Smith. And what happens then, the message that came clear to the capital, if you want, came clear into the market, was that, you see, if income per capita grows, in the beginning, inequalities will increase, only to decrease later on. So the message was, let's get richer, and inequalities will be reduced. Enter the guy you see in there, Thomas Piketty, with this beautiful book. Well, first 30 pages are absolutely breathtaking. Then it's boring like hell, because he bothered to check what, in fact, Kuznets had done. It wasn't wrong, but it was clearly what happened in the aftermath of a recovery for a major perturbation like Second World War. What happens now today is empirically seen as this. It's if you don't have read this beautiful paper by Newman, a mathematician on contemporary physics, etc., you have empirical data regarding the distribution of wealth worldwide. What happens is that it's something which is absolutely interesting. It's something about the self-organized systems in which the distribution of wealth worldwide follows a power law, which is like plotting straight on a log-log plot to simplify matters, etc., regardless of where you are, in Bangladesh, or in South Africa, or in Sweden, or in the US. The only thing, the total amount of wealth it changes, the integral, not the fact that this distribution is, of course, normalizes to one. But what is interesting is that the exponent matters, because the exponent almost inevitably is of the order of, say, 2.1, the empirical value that you get anywhere. 2.1 has lots of discussions on why the ubiquity of power laws have been under scrutiny for a long time, etc. But something, there's some important truth behind this. But if these were true, and this empirical data is what happens, you can calculate the total amount of wealth that you have in the system analytically. It's an exercise you can do to undergraduates. And what happens is that 80% of the wealth is in the hands of a 20% richest fraction of the population, anywhere, in Bangladesh and in the US, which is interesting because it's a system which is completely self-organized. And they say, well, what is this possible? Well, one of the things that I think I find absolutely fascinating about this new science applied, do you know that if you can count, for instance, in your own laptop, then you have a map of all the sizes of the files that you have generated. You can calculate them, therefore, it's easy to avoid binning issues. What you do, in fact, is simply taking the cumulative values of those probability of exceedance, the number of exceedances divided by the total, in which you calculate the frequency of your files. And you'll find something surprising. In your own laptop, if you work on that for quite a while, you have a same distribution, which is universal. In as much as if you take the distribution of the frequency of words in the Bible, in Moby Dick, which was the first exercise, or in whatever, tell me what kind of book that you have, and the women that, men that hate women or whatever, the distribution of frequency of words is the same anywhere. It's a universal factor. Nobody told, of course, your hand or the one of that wrote those books to do these things. It is inevitable. It's self-organized, critical, in a sense. And there's something which that probably gives, in fairness, that could be Chomsky that tells that the grammars, because it's different grammars, different languages, different epochs, whatever, even in Quran has been studied. And the frequency of the distributions of the world, there's something which this inevitability makes you wonder, in fact. It's something quite interesting. And let me get to easily the best hydrologist ever, very dear friend of many of us, very dear to me, Ignacio Rodriguez Iturbe, Stockholm Water Prize in 2001, and to describe him, I would use the words of a poet, Winston Hugh Auden, in archaeology, who said that knowledge may have its purposes, but guessing is always more fun than knowing. That's the poet, and that was our friend. Why this is important? Because what Ignacio has done has been to study one thing which it's my claim to the fact that we're inching towards a way of making compelling assessments, in fact, of ecosystem values, at least in one part of a landscape, which is the channel networks, the fluvial networks. And what he has found, in fact, is something coupled to the results of Benoit Mandelbrot, the guy who 3,000 years after Euclid, that was mentioned in the beautiful lectures in this morning of mathematics, that told us the obvious, which you haven't seen for centuries or thousands of years. It is the mountains are no cones, the clouds are not spheres, nor coastline are simple broken lines, nor does lightning travel in straight lines, in fact. And the other one is Per Bach, a good friend of many of us, who was a pioneer. He died at 50 of leukemia. It's a disaster. And of a self-organized criticality, something in which this scale invariance is a byproduct of open dissipative systems with many degrees of freedom. But rather than doing completely different things every time, regardless in the case of a structure of the aggregation of a catchment, regardless of the regolith, climate, vegetation, whatever, hydrology, rather than doing every time something different, they do always the same thing. And the universality of form, which you see in the river network, it's absolutely fantastic. And it brought, in fact, hydrology into a ball game much bigger than we used to manage from. Why? Because we do have exceptionally accurate data about the shape of the surfaces, in fact. And what happens is that essentially what you do, in fact, you construct, you put grids on that, you put von Neumann lattices, in fact, in those systems. And what you do, you can calculate different elevations, and calculate drainage directions. And what looks like a picture is not a picture, is a digital terrain model. So different from the astronomers that strive for the 2 or 3 orders of magnitude with due respect. But we can cover essentially landforms. Like when observed landforms, we have ground truthing, real ground truthing, not on Mars, but on walking on a place, from a scale of like maybe a meter, now more, now less, like 10 centimeters, to thousands of kilometers. We have 6 orders of magnitude. in the description of how a system works. At least, well, I'm not making distinctions at this point, but certainly you're talking about river networks in the runoff generating zone, which is something on which we can discuss. And that's the sign of this universality. Is you take a map of a river and you scrap the scale, you cannot tell whether it's the Amazon or it's a creek near here. Aggregation patterns have a statistical system which has an embedded universality regardless of climate, vegetation, you name it, or something. Not only that, it obeys a system in which you see here obeys a very important argument, which is finite size effect. That is, if you take like a large catchment, in this case, extracted, as I was saying, with these things, we're talking about spanning networks on a lattice, in fact. And what you're having there, you do have, but you have exactly the same distribution, and they die off, of course, when you have an embedded scale. That is, this is not a scaling variance over infinite number of scales. Is not for nature. At a certain point, you have a lower cutoff and you have an upper cutoff. And in this case, the upper cutoff is dictated by the size of a catchment you observe. And if you do the easy trick, it should be here. Yeah, the easy trick is say, so let's say the probability of exceedance, reason being, we avoid binning issues and something which technicalities, if you're interested, I can back forward to that. And you get that this is this 0.44. It's a common number that comes on, and it's an allometric exponent. It's not an integer. It's not 0.5. It's not 1. It's not 2. And that's a nice discussion over that. But what happens is that if you do that and you reproject these different scales, as you see in here, by simply saying that the probability you multiply it by the area to the, you invert the sign, of course, rather than minus 0.44 to 0.44, and you put area divided by the maximum area, they collapse into the same distribution. So there's a message in here. There's regularity. There's universality. And universality of form, that's what we have. Oops, there you go, wrong direction. Now, let's get the biological aspect, the ecological aspect into the picture. Because what I'm saying is that this, the thesis I'm going to try to convince you, there was actually where was recognized, and with recognition comes responsibility to advertise it, of course. But is that this universality of form oozes on the function of the networks as ecological corridors. And ecological corridors have important qualities, in fact, for evaluation of ecosystem services. Enter then Hubble, the universal neutral theory of biodiversity and biogeography, hated by many ecologists for the wrong reasons. I've been in some of in the academies, I've been in some hot debates because, of course, if you're a niche ecologist and the guy says that the guy makes the assumption that at the per capita level, biological rates are the same regardless of size. It's anathema. The point is, and later on it appeared, that neutral pattern doesn't imply neutral process. And on this, I'll be showing you an example right here. So what you have essentially these lattices spanning networks, details aside. If you're interested in details, I can flood you with them. And in this case, what I'll be showing you is an example in which we do have a completely neutral model that goes as follows into a von Neumann lattice and in a directional dispersal. That is something in which a neighbor is a neighbor because of a drainage direction. Something's given, it's a substrate for ecological interactions. It's not something which we invent. It's not like something which you attach to a problem. It is what's exactly. In the other case, you have the connectivity of a place which you have, here. If you have connectivity, have in this place are in the 4 directional coordinates. You can do better with 8 neighbors or whatever. And that's the exercise. So essentially what you have, the game goes as follows. And it's an interesting game because it's taken from the social sciences. It's the voter model. It was generated by political scientists, in fact. What happens is that just as you have distributional colors, like political opinions in a place, whatever value that you have. And you have distributions, different distributions at different colors are different, say, political opinions or different species. So the system proceeds as follows. You kill at random a place, and with probability P, you get a different opinion, a different species, or it is called diversification ratio in ecology. With probability 1 minus P, in fact, you will simply acquire the most numerous, you essentially, what colonizes the place that you left free because of a heating of a canceling of a thing, it would be a canceling of a species, would be the most numerous of the nearest neighbors. or within a kernel, or in the mean field, like the average of a system. The most present one is more likely, in fact, to affect the place that you have in there. And you let the system go. The diversification ratio is very important. You let it go until the system gets to steady state. And what happens is this: it doesn't take a statistician to see that there are very different patterns. The only difference between the two is the topology of a substrate for ecological interaction. It's a dumb model which has a few properties which make them absolutely irresistible in this case. But what you're having here, okay, now that's the result of that. Even what you have there called Savannah is the von Neumann neighborhood, and the other case is the OCN, but for a reason which would be too long to explain. But essentially, there is some fundamental implication of the directional dispersal, which is embedded in the nature of aggregated systems, which we have seen have universality of form in the system here. So what we did, and I'm very proud of that, in fact, a lot of work for graduate students, in fact, in my wet lab, we replicated the experiment. So we had something in which we generated a very rudimentary, etc., but very labor-intensive system in which we generated a system in which you had in every system we had something like 25 species of freshwater protists, for instance, and the dispersion was done manually in the system. So we regenerate, we make the experiment on the size of 90 well plates. We see what happens, and you keep doing that. And what you see in the system, it's the same. And there is nothing neutral about a living system with 26 freshwater processes in the system. So this is a real system. It's a physical system. They give us confidence that, in fact, this universality of form oozes on, in this case, biodiversity propagation that you have in the system. And that allows us to go from the infinitely small to the infinitely large. So we can do that. With that, we use the same model, exactly the same model, but was publishing well. In fact, it was something which you see LSR means local species diversity on an iconic river system, the Mississippi-Missouri river system, in which you had a very long, in fact, it was a famous biologist that collected the system in which you study freshwater fish, in fact, diversity in different places. And the second one, which you see here, it's AARP, very sophisticated measures, annual average runoff production. It is exactly something which is completely dictated by the size of the aggregation of the system. And it doesn't take, of course, we can dress the bride, as Ignacio kept saying for a long time, and then explain the statistics of that. But I mean, just look at that. It happens. The things are completely related. So that from the infinitely small to the infinitely large, we posit that we have the effect, something which is quite interesting, in fact, the idea that well, it doesn't matter. I was divagating as always. They call me, yeah, I'm divagating. My kids tend to tease me because of that. But what happens is that from infinitely small to infinitely large, in a system in which we have seen how, in fact, biodiversity, in fact, inherits that universality and the capability to predict its fate that we have seen for the form of a river basin, applies even to small scale. In this case, what you're having here is experiments, again, done in my lab, in which you have like École working on this running thing. We used to call it the protistodrome. We used to put protists in a place which is this size. In fact, in something which you do have a system in which you have diffusion of the system on timescales that are relevant to reproduction rate, to the rate of growth, in fact, of a bacterial community. And they move by diffusion. There's no advection in the system. And you have a system that has a particular filler. It has a very, I took it away. I'm sorry. I took away Fischer and Kolmogorov to shorten the presentation. The idea is that there is something which Cavalli Sforza and Albert Hammerman figured out in figuring out from archaeological data how, in fact, the wave of propagation of humans, in fact, the migrations in the Neolithic transition was measurable and relatively constant, meaning that the time scales of the process were enough. I mean, we're talking about propagation rates of the order of 10 kilometers per year or something. And that allowed to see the composition of human composition where we are. And you can do that fairly nicely. And these are the pictures that you take in these systems, which you applied again from the infinitely small to the infinitely large. In this case, is the invasion of the Mississippi-Missouri river system, which is also an interesting case, because what happened is that a Ukrainian cargo illegally dumped the ballast water too close to the inlet of the Chicago Canal, the one that connects what happened in the big lakes next to Chicago, in fact. And the veliges, that are the seeds, as I say, of a living quantity. In this case, the zebra mussel, which is a strong competitor in that system, invaded the system and started moving down through the system itself. In that case, as you see in here, what happened, you have the different values simulated and measured, in fact. And what happens is that it's quite interesting. So even migrations of this kind, is biological migrations, can be characterized fairly well. And the fact that you're using directional dispersal in the system is in fact the reason why this is so effective. One thing for the next generation that would be important would be something which is called catchment metabolism. I see that I'm getting close to the end of my thing, etc. I'll be cutting short on that. That means a catchment per se is a transporter and a transformer of material. Largely you can measure in gross primary production or in other cases, etc. And what happens is that quite interesting is that you have a fairly nice literature which focused entirely only on so-called blue metabolism. It is very, very consistent metabolism. It is where the sum of metabolism of all producers and consumers is used in measuring GPP or whatever you have. What happens in that, we have forgotten that this happens only in the so-called blue part of a catchment. It is only when you have rivers. There is a large part of the catchment goes unchanneled. In fact, Ignacio Rodriguez was convinced that the transpiration, for instance, the effect operated by plants and vegetation, the unchanneled part of the channel would cloud the other. And what Bernard shows is that both matters. That's something on which we shall return in the future. And the final part that I'm concentrating on is the fact that water and health, which is the triumph effect of the method applies to that in every case. That is in the case of a relationship between, for instance, one debilitating disease on which we worked intensely, schistosomiasis or bilharziosis. That's the ecological cycle in which essentially you get, as you see that the cercaria gets into the skin of a new host and lose the tail in the process. It's something in which you essentially, it's just the student that was working there only once dropped a pair of scissors, just picked the scissors and got the disease. What is interesting is that you can actually clean yourself by taking praziquantel, but it doesn't give immunity. So it's something in which it's a continuous cycle, etc. What happens is that the system is closed if you have, in this case, you have a migration. I mean, once it's excreted from the human body, which stays fairly well, as in feces and urines in different forms of a disease. They're called Manzoni or hematomium, depending on whether it sits in certain parts of a portal blood or in the urine system or in other places of a human body. The eggs hatch. They infect an intermediate host, which is actually the final host. The primary host is a freshwater snail that ejects thousands of those things. And as you see in here, it's a neglected disease, because what happens is that it gives learning impairment. It's a debilitating disease. It's a poverty reinforcing disease, in fact. Why am I saying all this? Because in this case, what happened with friends of mine, Jörg Gutzinger, Marcel Tanner, the group of the Swiss Tropical Institute, had a meta-statistic which is absolutely obvious. But that dam that I showed you before, one of the 15,000 dams that brought up the GDP of Burkina Faso majestically because of increased agriculture, doesn't bring in the cost of from 0% to 100% morbidity to the disease in the places in which those irrigation canals extended gigantically the habitat of intermediate hosts. So it's easy to make an economic comparison in which you put costs, you put the advantage by the GDP, but you don't put the cost because it has a cost, and we can compute that fairly well. And the very last thing I'm showing you in here, in which is there was a debilitating disease. In this case, it's Haiti in 2010, the poorest country in the world, that's struck by an earthquake that kills 100,000 people. And whatever infrastructure was left in this place, run by crooks for like 30 or 40 years or something, and that's the situation which you see in there. And you simply had, and I precipitated myself in there, and I was there. It was quite an experience, in fact. So this is simple what PAHO, the Pan American Health Organization, publishes on a daily basis. It is number of confirmed cases on Haiti, which is interesting for talking about the north and south of the world. Haiti has been cholera-free for 200 years. We brought it there with the UN peacekeeping troops for preventing looting. Some of them were from Nepal. It was health. They were just, they transported the disease. They were carrier of a disease, asymptomatic in there. But why am I saying this? This is nothing but the simplest possible thing you can have an undergraduate draw. That is cumulated number of cases in the different places in which you do have collection centers. And what you see in here, you see the rivers, of course, in a system in which there's no water distribution center, no pipes of any kind of anything. That is the distribution system. So it is clear the connection that John Snow, the Victorian epidemiologist who discovered it wasn't airborne, but it was a waterborne disease, realized like 100 years ago. And just only why did we do something? I was born academically and in Padua, and Padua is still under the spell of Galileo. Unless you can prove experimental results, you can show it mathematically with a little mathematics that we deal with, in fact, is never been described completely. So we can do, in fact, what we have exact results, for instance, of the stability of a disease-free equilibrium of a species persistence. This is two giants of a field, Ilkka, the late Ilkka Hansky, a Finnish guy who died very early, and the other is Marino Gatto, an ecologist of the Polytechnique of Milan. What we do is just we make spatially explicit models in which describe rivers where they are, in which we take human mobility from cell phone displacements. On this, I'll be closing, and it's my last time. I'm sorry, Giuliano, I'm arriving at the end. But what happens is that in this case, there is a system in which you calculate the bifurcations, the exchange of stability, essentially. So you have matrices, rather than what you essentially have is coupled ordinary differential equations. But you're not talking about one in which the compartment is Haiti, or one in which the compartment is a community in which you have susceptibles, in which you have infected, in which you have recovered persons in the system. So you have n nodes and 4 coupled equations. You have 4n times 4n matrices, but these are positive matrices. So you can calculate Jacobians exactly, and we calculate the saddle points through the transcritical bifurcations. And this is what we do. Not perfect for sure, but enough to advise about alternative management of the systems in here. That will happen in about a year in a system like that. And I'm getting to the last but heartfelt conclusion which I have. This is my last slide, and it's something which makes me wonder about the top-down, bottom-up approaches and the global north and the global south we were discussing earlier. And what happened here is that this lady with the red dress, oh, by the way, I love to take pictures. In this case, the pictures are kind of lousy because Terre des Hommes, the NGO that would take us around, said, okay, no, you don't have, it's bulletproof windshields. You can open because they can kill you to steal your camera. So that's to tell you what it is like. And the distribution network is what you see in there. And that's the market of Carrefour in the outskirts of Port-au-Prince, one of the most populated regions of the places. Again, there's no police, there's no government, there's no water distribution system, there are no roads any longer. But what happened in here is that this red lady, 1 second afterwards, after they put down the thing, went to the lady selling cabbages in there, showed the Nokia to that lady as a proof of payment. They got the cabbage in return. There's something funny about the fact that the northern world plans the infrastructure to get to the fact that access to safe water is socially biased, but the ownership of a cell phone is not. Anywhere in the south of the world, everybody has a cell phone. And whose fault is that? Oh, sorry, that's it. I'm finishing it with my conclusion. And my conclusion is that so I'm pessimistic. I'm pessimistic. I'm saying that I don't think we have any credibility in the south of the world. And the kind of agreement that will be necessary will be other things. So when I was the Stockholm Water Prize was announced in 2013, they asked me, the organization asked me to, they said that this gives you a megaphone that the world listens, and what's your message? And I want to repeat it because I really believe, which is underlying the title that I gave you, that is, I believe that the time is ripe to rethink distributive justice on water resources management tools, to reduce as a key to reduce inequalities on a global scale. And the message which I said is that when I travel in the south of the world and see that access to safe water, as I was saying before, is socially biased, but not the ownership of a cell phone, I doubt. And we cannot simply turn away our head, pretending not to see. Inequalities on a grand scale are the engine of migration, something which we know very much, especially in Italy. Thank you. Sorry, too long.